So how many of you have heard of Jetpack Compose before? Nice. How many of you actually use it? You, the lights are so blinding, I cannot see your people raising hands. Nice. How many of you here are Flutter developers? Okay. All right. So this talk will be about Jetpack Compose. So the way how we will be proceeding with this talk is we'll go through the pain points that we have with the current UI toolkit in Android itself, right? And we'll talk about the ideas that power Compose's new programming model, right? And then we'll look into some code, and then hopefully we'll try to do a little bit of coding at the end, if it actually works, right? So many years ago, I started to build applications for Android, right? This was several years ago, and it was just in, and then people wanted to build applications for Android because there was a huge demand for this, right? And then the kind of applications that we used to build back then were like very simple, right? People would just pay us to build soundboards, right? Applications when you click on a button would say something, and then people would gladly pay you for it, right? And then things were really good because we could really build these applications very fast, right? We would put everything into the activity. You would have like making network calls inside the activity. We would do all sorts of things inside the activity just to get quickly to the customer's hand and get paid soon, right? So this was nice. And then after a while, the market started maturing, Android started maturing. And what happened is clients wanted more. Like users wanted more and more things out of their Android applications. So when this started happening, it became really hard, right? Because the requirements were complex. The kind of things that we're doing with the applications were complex. There were like a lot of bugs that were showing up in production because we had nothing to do, right? And then since the business was also really good, then we also started hiring more people. And the more and more people that we added, we expected to ship more, but the opposite actually happened, right? We were not able to ship as fast as we could, and the problems only compounded. And then that was when I realized there is something called as an architecture, right? And then like, what is this thing? What is architecture, right? And I go and like do a bit of research, and then I find a lot of things, right? Like there are a lot of things that come into place. And I'm pretty sure like most of you would be using one of these, and you could also be people who are using something that's not even shown here in this picture, because you could be doing your own architecture, and if it works for you, it's totally fine, right? And basically, with any kind of architecture we're talking about, it's about these boxes, right? We have probably a view, and you could have 2 boxes, you could have 5 boxes, you could have 10 boxes, like based on the requirements. It could be any number of boxes. But at the end, what you're trying to do is like probably buy a movie ticket, and then the app tells you like, hey, it went through, like you can go watch this movie during this weekend, right? That's all is happening here, right? Nothing much at all. And with this kind of architecture in place, most of you would have reached some of these benefits, right? So separation of concerns, obviously, because instead of putting everything in one place, you know like where should my network calls go, where should my storage go, right? And you're starting to put these in different places, and then it starts to make a lot of sense. Yeah, this is where it is supposed to be, right? And especially if you have a large team, when people usually write code in their own patterns, it becomes really hard, because then there are territories. You have other people working on like different pieces of code, and you cannot understand their code, and they cannot understand yours, right? And people are also scared to go and work on some other places because you don't know, because the pattern is totally different. But with an architecture, there is some sort of similarity in the pattern itself, so which makes it easier for teams to collaborate, right? And we have, one of these advantages, separate concerns, right? And then there is maintainability, right? You no longer have this urge to rewrite an entire code base, right? Because oftentimes you feel like, damn, I give up on this code base. I have to go start from scratch, right? I have to do the same thing that I do 2 years so that the code base can be in the same position after 2 years, right? And you don't have this urge because now you have started writing code in a certain way, then maintainability becomes easy, right? And then you can also add a lot of business value to your users, because now it's easy for you to build new features, extend existing features, like based on your users' feedback, right? And then obviously testability, because you have separated everything. You have single responsibility, you have solid principles, so testability, like you also start reaping benefits of testability also, right? And then there's this, right? For anybody who has done any kind of architecture, this is one of the pain points that you'll talk about. You say, hey, everything is working out for us, but like boilerplate, not so much, right? And some of the architectures have like really large boilerplate, like unnecessary interfaces, and then people sometimes feel that it's okay to bypass these boundaries, and it happens, right? But boilerplate is not entirely a problem, right? Boilerplate is not entirely a problem because in terms of software development, there is always a cost. We try to do something and we always pay a cost somewhere in the entire development cycle, right? It could either be during development or it could be during testing or it could be during production, right? But there is a cost that you're supposed to pay, right? And given the fact that we can reap so many benefits from the previous slide, like all those benefits like separation of concerns, extensibility, maintainability, boilerplate is a very small price to pay, right? And I would like to think of boilerplate as columns in a building, right? Like you get into a building and then they're like columns, right? Even in your houses, we have columns. And sometimes we hide them in plain sight by like building walls through them, right? So that the pillars are not visible at all. And the size of these pillars can be varied, right? Like say, for example, if you go right down the hall, then you have these huge pillars in the hotel because the hotel needs these kind of pillars, right? And it doesn't make any sense to have pillars of this kind in our houses, right? Because obviously pillars are needed, but living space is also required. As long as the size of the boilerplate does not take more than what you actually require, then your architecture doesn't have a problem and you have made a fair trade-off. That's safe to assume. And this boilerplate can be written, like either we write it in code, write it by hand, because all the interfaces that you define to satisfy a contract, or all boilerplate that we write as developers, right? And sometimes this boilerplate is generated, right? It could be tools that help you find a view by ID, right? Sometimes it could be tools that help you generate layouts, right? Sometimes it could be tools that could help you via a dependency injection, right? So there is some amount of boilerplate. So either the developer, as developers, we tend to write these boilerplate, or we resort to tools to do this job for us, right? But there will always be boilerplate, right? But we have always been trying to reduce the amount of boilerplate that we write as developers itself. And one of the things that if you notice about Android itself, there are certain things that were designed 10 years ago, which worked really well during that time for the kind of requirements that we had and the kind of paradigms that we had, but not so much for now, right? Say, for example, if you want to build a screen that has a list of to-do items, then you probably start somewhere with an activity or a fragment, right? You write layouts, and for each layout item, then you start writing some more layout items. You give them IDs, then you have resource files where you define all your strings.xml. Then you can probably go define some styles, and if you're going to use some custom attributes, then define custom attributes. And you do all this, and then you come back to the activity and then wire them together, right? So there are multiple places where we do a lot of things, right? Say, for example, to show a simple view on the screen, it's not so straightforward, right? And in this case, it's really hard because the platform itself is designed that way. And you are supposed to do all this work in order to accomplish something as showing things on the screen, right? And as a community, I think we have been doing pretty well because if you notice, like maybe a few years ago, people would just talk about MVP or MVVM, right? But now people talk about MVP, MVVM, MVU, MVI, Redux. Like, there are like a lot of words like block. I don't know, like ribs. There are like a lot of words that are being thrown around, and it really works for a lot of different people, right? And if you notice the amount of boilerplate we have reduced from most imperative architectures to something like MVI is drastic, right? But there's only so much, right? And we are at a position where we as a community no longer have the means to reduce any more boilerplate in Android, right? And that's where Jetpack Compose comes in, right? Jetpack Compose, one of the objectives of Jetpack Compose is to reduce the number of boilerplate that you are going to write in your code base itself, right? And the way Compose works is it's a collaborative effort between the Android UI Toolkit team and the JetBrains team. And the way they do this is by leveraging the Kotlin compiler plugin, right? So Compose basically has two parts to it. There is a compiler plugin, and there is a runtime, right? So what Compose basically does is it can build tree-like data structures, and then it can effectively manage them, right? And it can target any kind of views, right? Not necessarily Android views. It can target any kind of data structure that is basically a tree, and then it will let you manage it effectively. So the current UI toolkit it works really well, right? But it also has some of the gaps, right? And that's where we try to use Jetpack Compose to fill all these gaps for us. So Jetpack Compose is an unbundled UI toolkit, which means this is no longer part of the Android framework on your operating system itself. So if you're going to work on, if you want a new widget, you don't have to rely on the support library to support the same widget on a different operating system, right? Your application just has to include this unbundled toolkit, and then you'll have all the new widgets that you're looking for, all the bug fixes that you've been trying to get rid of, right? So it's unbundled. It's not part of your Android operating system anymore. And it's heavily inspired by the programming model in one of these front-end architectures or frameworks, like you have React, Litho, Vue. So these are some of the web front-end frameworks which have made it really, really easy and effective for web front-end developers to build web applications. And if any of you has already tried the programming model with React or Flutter, you definitely know there is a way, like, the reason why React and Flutter developers say that they're able to build a lot of things in a very fast pace is because of the kind of programming model it offers, right? And Compose is also completely declarative. Declarative things are easy to handle, right? When I talk about declarative, how many of you love doing XML layouts? Even though you have an editor, how many of you prefer hand-coding your XML layouts? That's a lot. That's because why? Because it's declarative, right? You say, hey, this is a text view. I don't really care how you go create a text view. It's just a text view, and these are the properties, and you're done, right? So we enjoy doing it because XML itself is declarative, but XML is also limiting, right? And we have also seen efforts to minimize this limitations in XML because we have data binding, which lets you put code in XML, right? And how many of you like putting code in your XML? Damn. It's too bright. Yeah, but from the look of it, I think at least like not too many people were happy about writing code in your XML, right? Which again brings in a lot of complications for you. Then you cannot catch compiler errors, right? And you need additional custom tooling. You have to rely on the toolkit team to do things for you, right? So declarative programming is also very catching up a lot, right? When we say declarative, it covers the functional aspect of it as well, right? One of the examples that I can tell you that you will be able to relate to is probably I have a list of cars in an array, and then I want to filter out the cars that are red in color, right? So there are a couple of ways to do this. One is like go for the good old school for loop, say for I from this to this index, and if the color of the car is red, then add it to the new array, and then return the array, right? So you're focusing on allocating the array, going through the array, and then also figuring out a condition that matches for your requirement, right? And you can also do it like with a one line. You can say dot filter and then pass in a lambda that says, hey, if car.color is equal to red, then give me a new list, right? And in this case, you don't really care about what is happening underneath, right? It could be the same for loop that is under the hood, but you don't really care because you are operating at a much higher level of abstraction, right? And when you operate at a much higher level of abstraction, we end up writing very little code, right? And very little code means very little bugs, right? The code that does not have bug is the code that you have not written, right? So, and then you don't also worry about like allocating or memory management because all these things are handled by the framework for you itself, right? So what if we take all these declarative ideas and then apply it in a much larger context? And composition over inheritance, right? And like as object-oriented programmers, we tend to rely on inheritance for code reuse, right? So that's what I've been doing like most of my career, probably like I may be doing it even now. And that's when like you speak with the JavaScript people and then they tell you like, A is bad. You should do always a hash A, right? So composition is a much more effective way to reuse code, right? And you'll see why, because say for example, if I want to introduce a property, then I introduce at the top level. Like say for example, I want to have a visibility property, then what I do is like I go ahead and introduce at the top of the view hierarchy, right? And any piece of code, any class that inherits this piece of code will have a visibility attribute, which is a good thing, right? What if my widget doesn't need one? Like, what if I should make sure that people cannot hide this thing for me, right? So then what happens is like it complicates things because probably we will write a wrapper around it and prevent people from invoking this property, right? It becomes pretty ugly pretty soon, right? And say, for example, you want to introduce a properties only from a certain part of the subtree. It's not easy, right? Then we have to introduce an interface, and then the interface should probably have a property or a function which has to be implemented by all other members, right? And this becomes really hard to keep track of, right? So inheritance is okay, but inheritance is not the best way to share a lot of code, right? And this is also Kotlin only, because as developers move from Java to Kotlin, you start to see a lot of benefits of the language itself because the language is designed that way, right? And one of the reasons why this plugin is going to be Kotlin only is because Compose has a compiler plugin that intercepts calls to your functions and then makes modifications to those functions, right? So this cannot run on the JVM, and the Kotlin compiler plugin runs before APT, so there's no way this is going to Java. And it relies on using extension functions and other Kotlin capabilities to bring all these capabilities to the programming itself. And it's pre-alpha, right? So don't go wild west on this. Like, it's exciting, it does a lot of things, but you have to be very careful not to use this in production. And there's a reason why Google is doing a pre-alpha, because frameworks tend to change the way how people think, right? And the kind of mental model that we have towards building UIs is totally different, right? We think of views as objects, and we perform operations on these objects and change properties to achieve the things that we want to do, right? But Compose is actually going to change the way how we think and build UIs, right? And I'm not exaggerating this. It's how it is, right? So the community needs time to adopt to all these ideas, right? Because languages are easy. Because the moment, like when Google announced support for Kotlin, a lot of people who are doing Java jumped from Java to Kotlin pretty quickly because it's easy to adapt, right? Languages are easy. But say, for example, when you think about paradigms, switching from object-oriented programming to functional programming is really hard, right? Because it requires a change in thinking, right? Like say, for example, RxJava is hard, not because of the library, because of the paradigm shift that is required to use the library, right? And Compose will have some learning curve, but you'll also see that you will reap the benefits of that learning curve pretty quickly. But the Google Android UI Toolkit team wants to give us enough time for the community to catch up on these ideas, so that's the reason it's pre-alpha, right? And a lot of things do not really work well in Compose. Like there are like still problems running the plugin, there are crashes. There isn't enough tooling support in the IDE because sometimes your refactoring tools don't work, sometimes there are compilation problems, right? But that's understandable because it's pre-alpha, right? This is one of the slides. I will leave this for a moment. I like the way how Rich Hickey expressed this because most of the times we don't think like this, right? Because the kind of frameworks and libraries that we use have a significant way in our thinking patterns, right? They force the way how we think, right? The reason how say, for example, architectures in Android has evolved is because of the Android platform itself, right? Like the Android platform forces you to think in a certain way, and we as a community have tried all our best to make the best use of what we already can, right? So UI Toolkit it's a new paradigm to think about UIs in general, right? And the other thing that I want to talk about frameworks is one of the things that I find really hard when learning new things, the learning is not the hard part, right? The unlearning is the hard, because we have accumulated a lot of knowledge that over a span of several years that is really hard to let them go off, right? Like, and whenever we see something, we try to use the things that we already know, right? And most of you would be able to relate to this when you actually switch from Java to Kotlin. We tend to write Kotlin code, like Java in Kotlin for a while, right? Before we actually make idiomatic use of the language itself, right? So that's pretty much there. There are a couple of things. So I've been talking about mindset. So when I talk about mindset, there are two things I would like to make sure that you take away from this talk. So If there are only two things that you can take away from this talk, those would be the two things that I'm going to talk about, right? The first thing that I'm going to talk about is UIs or trees, right? For some of you, this could have come up as a surprise, and some of you like, dude, what are you talking about? Like, this is given. This is given. All kind of UI frameworks are modeled as trees. Like, why do you even have to tell us this? Because it's obvious, right? Some of you would feel that way, and some of you may think, oh, I didn't know this, right? But it's totally fine. In whatever way you feel, it's totally fine, right? The reason when I say UIs or models as trees is because even the current Android UI framework is modeled as tree, right? It's not a surprise. But the thing is, everything is transparent about it. We don't really care if the Android UI framework is backed by a tree or backed by something else. We don't really care because the APIs hide that information from us, right? If you want an ID, it just gives you an ID, right? We don't really have to care, oh, is it doing a breadth-first search to find this ID, or is it doing a depth-first search to find this ID? Like, I don't really care. As long as I get an ID, I can go use it, right? So the Android framework UI Toolkit has actually insulated the way how UI is represented, right? But Compose will require you to think UIs in terms of trees, right? That doesn't mean that you have to be really good at graph like tree algorithms or anything like that. You just have to understand the basic notion of trees. Like, oh, okay, there is a parent, there is a child. This thing changes, now what is going to happen, right? So that sort of thing, right? And the second thing if I want to talk about is this. UI is a function of state, right? So this is the second thing that I want you to like take away from this talk, because this is something that some of our folks have realized recently. So if you are using something like MVVM, then you know, hey, I know there is a state, right? And my view is listening to it and reacting to it. I'm pretty much set. Yes, you're true, right? And if you're doing something like MVI or Redux, you know, hey, there is a state object, and then what I have to do is like look into the properties of the state and then do whatever my view is supposed to do, and my view is basically dumb, right? But there is an intermediate object, like say, for example, a binding or a view renderer that takes this object and does the business logic on the screen, right? So when I say UI as a function of state, we are talking about state, right? At the end of the day, any kind of programs that we write ultimately boils down to a state, right? It's just a set of data that you have, and you're going to perform some operations on this data, like maybe make some network calls, like maybe talk to the neighbor, and then tell user what happened, right? That's all there is. So any kind of program that we do is just a basic set of data transformations, and then once the data transformation is done, then we communicate that to the user, right? It could be a JSON API response if it's a backend system, right? Or it could be a notification on the screen if you're doing front end, right? What if we can model the UI as a function that takes a state, right? What if your UI is just a transformation function that takes the state and produces the UI, right? And even if you notice here, the UI is at the left-hand side of the equation, right? Which means if your function changes or your state changes, your UI will change. But changes on the UI are not going to reflect anywhere else. Do you get it, right? So that's the most important part, right? Because now we sometimes set, like say for example, pull values out of the view or to do things, because the view is also stateful, the UI is stateful, right? But here, like the UI is just a side effect of the computation that you do on a piece of data. That's all there is, right? And this is the second point that you have to be like thinking about. So one is like UIs are modeled as trees, and the second one is UI is just a function of state, right? Talking about state, let's talk about this. Which two states am I talking about? That's not political. So like this is a nice looking screen, like, and obviously I did not build it. So if this is something that one of you could have built it, right? Like a lot of people among us, we would have built this, right? It's just a list of items on the screen, and it's really good looking, so I think I would enjoy building this. But how does this work, right? So regardless of any kind of architecture, you have some data somewhere, network, database, flat file, we don't really care, in memory. We take that piece of data, send it to the adapter. The adapter takes the data and then shows it onto the screen, right? Well and good, looks cool. What if I hit on the plus button? What do I do now? Do I have to change the state inside the list first? Should I say something has changed to my business logic, and the business logic will change it in the database of the network call? And will the network call tell the list view back again, hey, have you changed? Right? I'm pretty sure like we would have debugged a lot of bugs in recycler views, right? You expand the third item, and then you scroll down, then the 10th item is expanded. Right? Happens. And we set the breakpoint, and then I figure out, where is this happening? Is the adapter doing the right thing? Who's the bad guy here? Is my adapter the bad guy? Is the database the bad guy? You never know. Probably the person opposite to the desk. Right? So if you look at these class of bugs, this could happen with any kind of component, right? List view is something that we can all relate to, but because they're like too much state to manage. But there are also other components where this could actually happen, right? And basically what we are trying to do is we have two pieces of information, one which we trust more, one we trust less, and all we're doing here is to take this data from this place, put it over here, and take this data from here, put it over here, right? All we're trying to do is just synchronizing data between two different places. That's all there is, right? And if we think about this equation, if your UI is just a transformation on a piece of data, then we get to eliminate this entire class of bugs. We don't really have to care about these bugs because you're not synchronizing data between two different states, right? Okay, we know what the problem is, but how do we solve this? There must be a way for us to solve it, right? Because if we don't have a solution, then we probably it's no use for me to stand here and talk about this in the first place, right? Why will I be talking about this? So we understand the problem really well, but what are the steps that we take in order to fix this problem, right? That's what we're going to do. No more references to views. And in the Android framework, obviously I don't do this in production, so please don't take pictures and tag me in social media. So there is a text view, and then I'm doing a println on textview.class.java. What am I going to get? Android.widget.textView. Expected, right? All right, let's do this in Compose. What is this? A similar primitive that lets you draw text on the screen, right? All right, I don't know. What happens here? Sorry? What does it print? That's interesting. It's like, you can invoke text, but I'm going to give you nothing, right? If I don't give you nothing, then you cannot read state from me, right? Now the text view is essentially telling you, or even if it's a list view, you can put things here, you can set state, but I'm not going to return you a state. Now you're on your own, right? So this is an interesting model, it's a new problem. So that's the reason why we, as programmers, we think about everything in terms of objects, right? And we tend to solve problems in a certain way, right? And Compose is going to tell you, hey, slow down, it's going to take some time, but we're going to be in a better place than we are in now. And probably a lot of people will have a lot of backlash, right? But slowly people will realize, right? Because we are human. So what is this text? It's a function. It is a function, in fact. A text is just a regular function, right? So if you look at it, it has regular properties, and then it does more things, like probably drawing things on the canvas, measuring the size, position, text, and then it's marked with composable. So in composable, if you want to build UIs, we define a regular function, right? And the function is marked with a composable annotation, right? And what composable does is, if I may, we talked about how Compose is a system that is built to manage trees like data structures, right? So when you mark a function with Compose, what it essentially does is it when it executes the function, it emits a node into the tree, right? And the way we build UIs is call a lot of these functions, one after the other, or like maybe nested calls. And then each of the function call will emit a node into your tree, right? Now what you have is like a huge UI hierarchy. You have a large tree, and then you have nodes that are listening to changes in the data, right? And when something changes, Compose finds what has changed in a very specific part of the tree. It could be a subtree or it could be the entire tree, and then it does the smallest operation possible to re-render the tree, right? That's how it works, right? That's how Compose works. And it also is semantically, it has very similar semantics to coroutines, right? Say, for example, you have to call a suspend function from within another suspend function, right? And similarly, a composable or a compose component should be called from another compose component, right? Those are very little rules, but pretty much you can use the same kind of skills that you use to organize code, right? Because a lot of times when we work with XML, I'm pretty sure, like say for example, I consider I have some decent programming skills. I can organize code pretty much well. But when it comes to XML, styles, colors, I know there's a lot of room for improvement because my knowledge as a programmer or a developer organizing my code does not translate to knowledge in organizing my XML files, right? But with Compose, since everything is everything is Kotlin, say for example, your style, you have first-class support for styling, you have first-class support for colors, theming, and then all the UI elements. So you can go ahead and use your existing programming skills to organize the code that the way you really want them to, right? Let's start with this. Let's start with a very small example and then see how this is going to look like. I'm not going to build something very complicated. And also take a lot of things with a grain of salt because I'm also pretty new to this paradigm. I've done my due diligence to make sure that the code that I show is like really as good as possible. Like I got some help from people who know this stuff really well. But don't take this as a best practice or a guideline because Compose is not out there yet, right? Like because when Compose comes out, then we would probably have different practices and things like that. And also it's pre-alpha, so just take all these ideas with a grain of salt, but I'm not suggesting that you go apply this or do the same thing in production. So now it's a very small, simple UI, right? So we have apple, and then there is the total price of the apple, then there is a stripper. You have a minus button, then you have the number of quantity, and then you have a plus button, right? That's pretty simple, pretty standard. And in Android, it's pretty easy to do. Let's see what I can do here, right? Let's think about this for a moment, right? We said UI is a transformation function on the state itself, right? You give it a state, you create a function, then you get the UI. That's the basic idea, right? So the first thing that we're going to focus here is the state itself. What is the state here? Sorry? Number of apples, if we had more apples, exactly. Here is just like one apple, right? So we need all information related to the apple, then it's probably a fruit class. I'm pretty sure like most of you thought about it, but did not say it out loud. So we have a class that says fruit, and then there is a name. There's this class. And then we have a name, which is a val, right? It's a immutable variable value. It says val. And then we have a price, okay, also immutable, like doesn't change. And then we have a var, which is mutable, the quantity itself, right? And then we also have a computer property that says get total price, right? Which is again a val, right? It's just a getter, like no backing, not backed by fields, right? And then we also have a model annotation on this. So model is a part of, it's also part of the Compose runtime, compiler as well as the runtime. So what model does, it says, hey, if this class has properties that change, make sure to notify its observers when something changes here, right? Say, for example, if you're going to bind this property to a text view, and if this property changes, then your text view is going to automatically update, right? And then we have this total price, and if you look at the total price, it's actually a val, right? But the property that it is operating on, say, for example, here, the quantity itself is mutable, right? So it says, okay, this computer property depends on a mutable value, so if there are people who are also listening to this property, let them know if this is updated, right? Pretty much it. And the state part is done. Let's now do the function part, right? Let's go ahead and build out this function. So if you look at this UI, we're going to build out this component first, right? So when I talk about stepper, there's no stepper in Compose, right? Because Compose does not have a lot of standard components, and stepper is something that you cannot expect to have in Compose itself, right? So the first thing that we're going to do here is what? Define a function, right? So we're going to define a function that's called stepper. It's pretty standard, nothing fancy. I'm not teaching you anything new. There's a stepper function, and then it takes a count, and then it takes a on-count change callback to notify people who are listening to the count change. All right. And now if you look at the stepper itself, you need something like a linear layout with a horizontal orientation to put things one after the other, right? And that's where we have something called as a row, right? So we have a row, and then we want to put something inside it, and which is going to be a button, right? There's a button which has a text property, and I'm setting the text property to minus, right? Which means, yeah. And I want to add some space between my button and my text so that it's not too close to each other. So I'm going to set a width spacer. It's a component that, it's again a compose function that I'm invoking here. And if you notice the parameter, it's 8.dp. How many of you can, from the top of your head, can say how to compute dps given some pixels to you? Screen density then? Constant then? I don't know, honestly, I cannot remember this from the top of my head, right? Because that's the way it is, right? But at least in Compose, you don't have to deal with it, because if you have a float or a double or a number, and then you can call .dp an extension property on it, and it'll compute the properties on you, right? So you can safely type, it brings in type safety, so you can operate on these values with confidence, right? If you're going to operate with fonts, then you can say, hey, .sp, it would work, right? And we're going to say, I want to have this, my padding is supposed to be this much, and then you can always say the unit that you're interested in, right? In fact, if you want to do things in pixels, you can also do a .px, right? And then again, I also told you that we favor composition over inheritance, right? And this is where container comes in, right? Because text itself does not have a width property. Because if you want to have a component that has to have a specific width, you wrap it inside a container property, right? So which means your code is very small. You can compose different kind of things, right? Say, for example, if a component does not have a width property or some other random property, you can still write your own compose function and make sure that your compose function operates on its children, right? So that's what we're doing. And again, pretty much standard text. And in the text, I'm going to set the text property to bind to the count property itself. Right? Feels like XML already? No? And then I'm going to say style, right? I'm going to say, this is the style, and I want my text to use the body one style, right? And the lambda here, it's type safe. So if you're going to do a control space in it, you'll get this list of styles that are applicable in this context, right? So you're not going to get invalid. Say, for example, the autocomplete with XML is very restrictive, because if you're going to try to search for a style, then you're going to get a lot of matching properties, which can be very confusing. And then again, I want to add some space after my text width spacer, and I'm going to add a button plus. We are pretty much done with our layout. I think in terms of UI, I think you're convinced that we are done, are we? Yeah. So in terms of UI, we are done. What about the functionality? What about the click events, right? That's something that we have to handle. So we're going to say, minus button, when I click on this, something should happen, right? A count should decrement. So I'm going to say, if count is greater than 0, that is, okay, this is not the final API yet. What we're essentially trying to do here is we are disabling the button when the count is not, it's 0, right? So in Compose, the current way to disable a button is to make sure that the clickable property is null, right? And this is not a final API. There could be probably an enabled property that you can flip on and off, but this is just temporary, and this is how it is today. So if the count is 0, then we're going to disable the button by setting it to null, or else we're going to say on remove 1. And on remove 1 does nothing, right? It's just a function that has a callback, and it says, hey, call this callback, invoke this function with count minus 1, right? And again, with plus, we're going to do the same thing. On click is, we have a listener, and then we say, add one, and then we do this, right? Sounds good? Do you see any state here? Sorry? Do we have any state here? Do you see assigning, or like, are we getting hold of any piece of information here? The button is completely stateless, right? The stepper is completely stateless. If we were to do the same in the current Android UI Toolkit, it's really hard, right? It's almost impossible because the button, like we'll probably have a XML layout with the buttons and the text view, and we would have styling information somewhere else, and we would have a Java or Kotlin file that would wire this logic, and we would have a count property inside which gets managed, and you write override saved instance state so that you can save the state and restore state, right? And then you do a lot of things, and probably it may work, right, the first time. And this is all you have to write to build the component that I showed you earlier. And this is boilerplate destruction, right? Like we just completely got rid of the boilerplate. There's no boilerplate in here, right? That's amazing. And yes, of course, the composable annotation on the top of the function, right? Let's try out building the entire component here. Let's try to build this row. And we start with the fruit row, which is again a simple function, right? It's annotated with composable so that it can be called from other composable functions. And we're passing in a fruit because UI is function of a state, right? UI is produced by a function of a state. We have padding, and there's a padding property, and then say edge insets left is 16 dp and right is 16 dp. So we have spaces at both sides of the row. And then there's a flex row because the stepper can occupy some space, but we need the text to occupy the entire space, right? So we say expanded, and then like we are just telling this text, hey, go ahead and take all available space after all the components in this layout has taken their space, right? And then like the flex row takes all the available space. And the text property takes the name of the fruit and the total price of the fruit, right? And again, we are going to specify the style here. It's a H6, I guess, yes. And then we say inflexible, and then we put the stepper here. We bind the count property, the quantity property to the count, and then we send a callback. And whenever this callback is invoked, then we go change the value of quantity. Pretty cool? And this is all you have to write to create the row. You need dividers, you go add a divider, right? There's no XML, there is nothing, right? They're like, basically there's no ceremony that you're supposed to do. Like you can pull all this off with just the setup. So this is also done. But where is state? Right? We have to hold on to the state somewhere, right? So this is an overridden function on an activity. It's not even an app compat activity, it's just a regular activity. And set content is the way how we hook the compose system into the existing view system. It is an extension function on activity, and there's a bunch of boilerplate, which you don't really have to write. And then there is a fruit app. So fruit app has the style of the entire application setup. So material typography, colors, and things like that. And wow, okay. So when I talk about material theming, Compose actually lets you change themes on the fly, right? Because currently we cannot do that without an activity restart, right? So Compose actually lets you do that. It's because material colors is just a data class, and the moment you switch the data class, things will render differently automatically, right? And they also have linear interpolation function on text, colors, and shapes, which means when you transition between themes, that would actually animate, right? These are things that does not exist. You can still dynamically switch themes, but the linear interpolation is still not present, right? And here we have an apple, and then there is Memo, and then there is fruit, right? And then there is fruit row, right? And now that you may ask, like, what is this thing? Like, what is this plus Memo, right? So what is plus Memo? So any UI frameworks that we use these days, they help us do two things, right? One is how do you do state management? How do you change the state of your system? Second thing is like how do you do effects, right? Effects are anything that could change things in the real world, right? Maybe it's a state that is outside the scope of your function, right? Maybe you're writing to a disk, writing to a file, like doing anything else, right? So that is what a effect is, right? And global state is also an effect. So the way how Compose works is when you run this program, it invokes all the functions inside it, right? Say, for example, fruit app is a composable function, right? Fruit row is a composable function. And what a composable function does is when you give it a piece of data, it's going to emit a node, right? So if you look at this, fruit row itself has multiple children, right? And then it also has a stepper, and then stepper has multiple children, right? Now, if you can imagine when every compose function is executed, a tree is constructed, right? And when a tree is constructed, it's all there, right? But there are subscribers that are listening to mutable changes, right? Here, quantity is a mutable value, right? And the moment quantity changes, Compose is going to do a recomposition, right? What it's going to say is like, hey, this part of the subtree has changed. I'm going to rerun all these functions again, right? And when it does that, it calculates the difference between the old tree and the new tree, and then recomposes that tree, right? So there is compose, which is like doing the first pass to construct the tree itself, right? And then there is what do you call it? Reconciliation and reconciliation is where you find the difference between the old tree and the new tree and the old tree. And then reconciliation is where you recreate the nodes that have changed, right? So when I say that, recompose is going to trigger every single function, right? Technically not only the ones that have changed, but let's think of it that way. So let's say I'm going to change quantity, right? And then that is going to trigger a recompose, right? Which means all functions will be executed again, right? And when that happens, if the fruit is declared here, we're going to create a new instance of fruit, right? Which means the quantity of the fruit will never change because you have a new instance of the fruit, right? What Memo does is it's an effect that tells you, hey, this is a piece of state, and when you do a recomposition, I don't want you to forget this, right? And what Memo does, it takes the position of this object in this place, and then it caches it. And when you do a recompose, that part does not change. Compose retains it for you so that all those new values show up on the screen, right? That's why we use effects, right? That's the idea. So there are a lot of ways how you can do effects, like accessing global state, making network calls, and things like this. And the plus is a unary plus operator overload that currently works, but this probably is not going to be a convention. They probably would merge this into the compose system itself. So an effect would be a function that returns a value, whereas a compose UI component would be a function that returns a unit, right? I don't know how that is going to work, but that's certainly in progress. And I hope we'll probably not do the demo. I don't think we have enough time for the demo. But let's say, so in terms of the future, you can obviously see a lot of productivity because we'll be writing a lot less boilerplate. We'll be using existing skills in multiple places to organize our code and things like that. It's a much higher level of abstraction, which means we as developers can focus on delivering a lot of value for the business, right? So we can focus on delivering business value rather than plumbing XML layouts, styles. And it's a wider use of existing skill set. So if you are really good at writing code, you can still go ahead and write code, focus your time on writing code, right? That's all you have to do. And collaboration is going to be pretty easy because one thing is design team, if you're going to work with a design team. And some of the design teams that I know of, they have sketch files, and these sketch files have components, right? I think the right term for this is called as a symbol, right? So when the design team shares this with you, they have predefined components created for the entire application, right? And most of the teams try to recreate this, and some succeed, some don't. Uber has libraries that help them do this, like Artist and Stylist. And there are companies like Gojek who I think they have a project called Project Asphalt, which is moving in this direction, right? But since all this thing is Java code, you don't really have to wait to like fix your typography, fix your styling, fix your components, because you can just go write code and then share it with everyone, right? Because packaging is something that you're very familiar with. And product also, because one of the things that's really hard for us now is to build prototypes. Like the moment someone tells A/B testing, like we're like, wow, like do you really need it, right? Because it's so hard to build these things, right? But with Compose, prototyping is going to be really easy. If you're going to try something and then you're going to test it in the market, you can go really fast and test it out. And possibly other platforms, because Compose just targets tree-like data structures, right? And there's an adapter that actually renders this onto the screen. So you could probably target Android, maybe iOS, maybe desktop. I don't know. It could be anything. But it's just a speculation. But the way how the community is moving towards Kotlin multi-platform, this could happen. I want to see where this goes. And this is one of my favorite treats. So over time, we get used to things and we get really good at it. And when something better comes in, it's really hard for us to change, right? So the good things stop us from having better things. And Leader Richardson is one of the person who's working on the Compost team. Yeah, this is also one of my favorite notes. Here are some resources that you can go ahead and look at. Quite frankly, there are not a lot, but you should probably go participate in the Slack community. There is a Compose channel where you can ask like any sort of question, and people are super welcoming. It's okay to ask like any kind of question that you feel like asking. There's nothing wrong, because I find the community very friendly. The engineers are very friendly. They answer you like it's pretty nice. And that's it. This is my Twitter handle. And if you think I don't talk, like you find something useful, then you probably follow me here. And I think we have a few more time for questions. And if you have any questions, I'm up for it. Yes, please.
So in the stepper code, we have if count is 0 in the click listener. Instead, we can have it outside the button itself. Is it possible?
You can do it. Say, for example, let's say you find it really hard to set the click listener to null. So what you can actually do is say, hey, I'm going to create a enabled compose component that actually does this logic for you. So you can pass the enabled compose component a conditional and a lambda, and then you can use that function on top of other compose functions, and then they will behave accordingly.
So
Yes.
does the context take on its own? I mean, if you define it as a composable, does it take the context on its own?
No. So Compose gives you something called as a composer. There are like a couple of ways to do this, right? Compose has something called as a composer. So it is usually imported to the top level of the project. So you can do composer.context to get the context itself, right? And there is also something called as a provider mechanism, which is like which has really caught up in the Flutter community. So what provider does is when you look at functions, like say for example, I have, I want a string, but I want to pass it, I have a context, right? But I want to pass it down to like maybe 5th level in the function, right? Now, all functions should have a context parameter, right? Because you're passing it explicitly. This becomes really hard, right? So one of the ways to fix this is to pass these dependencies implicitly, right? So Compose gives you something called as an ambient, right? So you can say ambient is like a module to Dagger, like. So you can say, hey, these are the dependencies I want to pass down implicitly, and then you say ambient and then the provider, and then you can provide that instance, right? And if I'm a function downstream, I can say ambient of context, and then I can get access to the context. So there are ways to implicitly pass dependencies down the tree hierarchy. Yeah.
I have one more question. Does Composable Jetpack also provide other functions? Like you used set content to fill the entire screen with this float row, right? But what if you wanted add view or something like that? Like, do you?
Okay, so there are native view adapters that let you use
No, because
either the existing Android view system or the I don't really know the answer to this question.
Because normally if you define text views in the old way, you need to like get an instance of the layout, and then you need to add view so that it goes and fills in the view. Here you have just put a memo class, right? And it assigns so much space. That's what you said.
No, memo is for the state.
Oh, for the state.
Because during recomposition, you don't want to lose that information, right? Because if that gets called again, then your state is reset to the new object itself, right?
Okay.
That is something that you don't want to lose.
Okay, but where does it add in the layout? Like, is there an add view class or something like that in
There's no add view class, like, because if you want to add view, then you have to have an instance of the class, right?
Correct.
But the reason why I mentioned that you have to think of in terms of trees is because whenever a function is invoked, it creates a node in the tree itself, in the UI tree. Yeah.
Okay, so in that case, any activity you use or any fragment, you have to use set content, and then like within that you have to create a tree.
Correct.
Within that another tree, another tree. So a component of components like that. That's
Yeah, but like you will not have the performance hit in this case.
okay.
You don't really have to bother about nesting and all these things.
Okay, I understand. Okay.
Yeah, because even when you look at the, say for example, if you go to your layout inspector and if you inspect the layout itself, they're like completely flattened.
Yeah, the unary operator overload that you
Yes,
used.
yes.
If memo is the thing which is controlling, which is
Memo.
not like recreating the component, then what does the unary operator overload do?
Memo is not recreating the operator.
It's preventing the recreation.
It's
right?
preventing the recreation. Yes.
So what does the unary operator overload do in that case?
Well, that's just a DSL in terms of Compose.
Okay, so
And that,
is that the same reason why style also has the same unary operator?
yes, because when you do plus, then you're accessing the global state, right? Which is
Okay.
again an effect. Yeah.
Okay, and-
So all effects in Compose will start with the plus operator.
Okay, okay. And since like the composable annotation components can have lambdas internal to them, do you actually need to inline those functions, or they are inlined automatically by the
You don't have to inline
annotation
them.
processor?
You don't have to inline them because they're like just normal function invocations.
Okay.
And currently inlining is also not supported.
By the
And I don't think inlining will also be supported because of the way how trees are constructed, right?
Okay.
I would suggest Leland Richardson's blog on Compose from first principles.
Okay.
And they talk about how this tree is exactly constructed, right? But if you're going to inline these things, then they'll use a lot of techniques like memoization, positional memoization, and then they use grouping to actually make sure that when you reconcile, you do the minimum amount of operations, right? That actually relies on the structure of your source code, right? They pick up keys from the position in your source code to group them together.
Map,
yeah, so like a lot of things are happening. So inlining, I don't really know how inlining would work, but this is a really good question that you can ask in the Slack channel. Yeah.
I will. Thank you.
So yeah, quick question, like, were you able to try Swift UI?
I did try to do some demos. It looks pretty similar.
Yes.
I liked the preview provider.
Yes.
The feedback is pretty good, but the tooling in Compose is not as good.
Yeah, means like the Swift UI means what I saw was that it's not at pre-alpha, like it's quite beta.
Yes.
It's quite stable.
Yes.
So like in terms of if you see Jetpack Compose, or like means just comparing Swift UI with Jetpack Compose, like in how much time we will reach there?
Okay, this is, I don't know,
Like means just kind of a,
I don't know, but I'm also, I think this is just coming from me. I think it'll probably take a year to, like even year or more. Like I wouldn't be surprised if it takes 2 years for us to actually start using it.
oh,
It's just me, like the team is hard at work. Like I don't know what Google plans are. Like I have no clue. And I'm speaking for myself. It's just my opinion.
okay. And since this is unbundled, like it will be like going forward, we are planning like it can be used for 5 till 10, right? Like means Android versions.
Yes,
It
yes. If it
should
is
not be-
unbundled, then you don't have to, as long as you include the dependency, you don't have to worry about older
Yeah.
versions of Android. Yes, correct.
Thanks.
Okay, so my question is, this, like you have written 16dp,
Yes.
16.dp,
Yes.
like we write in XML, we use something like 1x space or 2x. So is there a way to do the same thing, or we just make, like they tell us to make separate styles and use them?
So currently, the styling and theming is also pretty primitive. Like say, for example, if you look at the material specification, then we have the material typography, which gives you buckets of fonts, right? And it also gives you a bucket of colors. And currently, material typography and material theme are data classes. So you have to pass them in, and there's no way to inherit a data class, right? So if you are going to have your own buckets and you want to call them differently, I don't really see how this can fit in right now, but it's probably like, as I said, it's pretty early pre-alpha. They're getting feedback from the community, and you can still bring this up in the Slack group if you really feel that there should be other way to do it. Because personally, I also found it limiting because like buckets could be different, right? Fonts could be different. Like we want to call them differently. But currently, there's no way to do it. You have to use the same material notions to do it. Yeah.
So you had briefly mentioned recycler view in the beginning.
Yes.
So is there a function that allows us to work with recycler
Yes, there is
views
going
right
to be
now?
a function for recycler view, and it's going to be pretty interesting. It is not there yet. I think like there are some prototypes, but I think when you basically have a recycler view, you will probably do recycler view, pass the object, and then you get the list of objects, and you can iterate them because you're still writing Kotlin code inside your functions, right? So you can say for food and like a list of food, you can iterate them and then say add this row, and if it's of this type, add this row, right? And then the recycling thing will all be part of Compose itself. Anything else? I think we're done. Thank you very much.